Hi, everyone, and thanks for joining me for this lesson on momentum. We are going to look at this question here, which says that we have a 0.04 kilogram cardinal and a 0.145 kilogram baseball, and they're moving with the exact same kinetic energy. Using that information, we want to figure out which one of these two objects has the greater magnitude of momentum. Now let's start by looking at the first line of this question. It tells us that these two objects have the exact same kinetic energy. So we can write that the kinetic energy of the baseball is equal to the kinetic energy of the cardinal. And now we need to ask ourselves, what is the equation for kinetic energy? Well, kinetic energy is equal to 1/2 mv squared, where m is the mass of the object and v is the object's velocity. Since we know that both objects have the exact same kinetic energy, we can replace kb and kc with our kinetic energy equations. That leaves us with this. 1/2 mb vb squared is equal to 1/2 mc vc squared. Notice how I use the subscripts to keep track of all my different variables. Now, looking at this equation, there's a very quick simplification that we can do. 1/2 is a common factor on both sides of the equation, so we can cancel it out just like this. Now let's pause here. We are asked which of these two objects has the greater magnitude of momentum, but we have not yet related momentum to our equation. We know that momentum, P, is equal to mv, where m is the mass of the object and v is the object's velocity. We want to relate momentum to the equation that we have from the kinetic energy. So let's rearrange the momentum equation so that it looks like v is equal to p over m. Now, using this equation, we could say that the velocity of the baseball is equal to p over m. And we could say that the velocity of the cardinal is equal to p over m. And we could take these values for the velocity of the baseball and the velocity of the cardinal and substitute it into our kinetic energy equation. So let's do that. Looking at the left side of our equation, we will replace VB with PB over MB. And remember to square it because the velocity in our kinetic energy equation is squared. Now looking at the right side of our equation, we can replace VC with PC over MC and remember to square it. Now, all we need to do is simplify this equation. And when we do that, we're left with this. PB squared over MB is equal to PC squared over MC. So we've taken our kinetic energy equation, we've related it to momentum, and we're left with this. Now, all I want to do is rearrange this equation. So we're going to get our momentum variables on the left side, and we're going to get our mass variables on the right side. And that leaves us with PB squared over PC squared is equal to MB over MC. Now, the last step is to get rid of the squares. How do we do that? Well, we take the square root of both sides. And when we do that, we're left with this equation. And with that, we have the equation we need to answer this question. All we need to do is replace our MB and MC values with the mass of the baseball and the mass of the cardinal. Then when we do the math, we can see that PB over PC is equal to 1.90. But now what does this mean? Well, what we did is on the left-hand side of our equation, we have a ratio that's comparing the momentum of the baseball to the momentum of the cardinal. And what we found on the right-hand side of our equation is that the momentum of the baseball is 1.9 times bigger than the momentum of the cardinal. And let me rearrange this so it'll become a little bit more clear for you. You can see when I rearrange the equation, now it states that the momentum of the baseball is 1.9 times the momentum of the cardinal. And that's one way you can answer this question. We took the equation for the kinetic energy and we related it to the equation for the momentum. And in doing that, we were able to create a ratio in which we were comparing the momentum of the baseball to the momentum of the cardinal. Now, this question came from my grade 12 physics student. Her teacher assigned this as a homework question, and she came to me saying she hated this question because she didn't know where to start. She knew what the kinetic energy equation was, she knew what the momentum equation was, but she had no idea how to relate them. And that's why I thought this was such a fantastic question, because normally we may just take an equation, input numbers, and just get an answer. But this question requires you to take two equations to understand how they are related. And then through that relationship, you get another equation that you can use to answer the question. That's pretty high level. That's a university level question. And so I love it because it challenges the students not to just plug and chug into their calculators. They actually have to think about the variables, think about the equations, think about how they can change the way the equations look, and then substitute into different equations. I love that kind of thinking. And I think it's a lot more useful to get students to think like that rather than to just use an equation, plug it into your calculator, and get an answer. To be honest, computers can do that so easily that it's actually better to train the students to see relationships between equations and to understand how to manipulate variables. That's where the real thinking comes in and the real thoughtfulness. So I love this question. I hope you had fun learning this question, and let me know in the comments what you think about questions that challenge students in this way. Anyways, thanks for listening. It's Easter weekend where I am, which means we get a long weekend and we get some time to relax, have fun, see our families. So I hope you get to do all those things, and I hope you just have a nice rest of your day. See ya.